Mathematicians, today we see a very nice problem in real analysis. This problem, the similar problems using the same concept, it has been asked many times in CSIR exam. Okay, so it is a very important problem. Let's see how to approach this problem. Let I equal to set with only two elements 1 and 2. Okay, now for each x belongs to R, we define a function pi of x. Pi of x equal to distance between the point x to the set I. Okay, so in real line we can find a distance between 2 points. Okay, mod x minus y will give you the distance between x and y, but here we are defining a distance between a point and a set. Okay, so how to find the distance between a point and the set? So you have to, so this point x is fixed. Okay, so this x is fixed and this y is varying over all the elements of the set I. Okay, so for you have to find the distance between this point x and all the points of the set I. So you will get many different distances. You have to take the infimum of all those numbers. Okay, okay, so this is our definition of pi of x. Then the options are: pi is discontinuous function, pi is continuous on R but not differentiable at x equal to 1, pi is continuous but not differentiable at x equal to 1 and 2, pi is continuous but not differentiable only at x equal to 1, 3 by 2, 2. Okay, now one thing we want to observe here is, now this I contains only two elements. Okay, so distance between x and I will be, you have to fix this x. So you have to calculate distance between x and 1 and distance between x and 2. There are only two numbers, two different distance you will get because I contains only two elements. So this set contains only modulus of x minus 1, that is distance between x and 1, and the modulus of x minus 2. Okay, now so you want to find infimum of this set, but this is a finite set. For finite set, calculating infimum is same as minimum. So we get pi of x, which is equal to distance between x and I, that is equal to minimum of mod x minus 1 and mod x minus 2. Okay, so this is one definition of the given function. Okay, so let's see how to proceed and solve this problem. So if you are new to my channel, please subscribe to my channel, and if you are like my teaching, please click the like button in my videos. Let's continue. So now we going to approach this problem in two different directions. Okay, first I will tell you one jump. First we solve this using some diagrams. Okay, okay. So we want to draw the graph of this function pi of x. Okay, so let's see how the graph of the function pi of x looks like. So now maybe here I'll just write the definition of pi of x. So pi of x equal to minimum of distance between x comma 1. Even we know the distance, that is mod x. Okay, let's write distance between x comma 1, distance between x comma 1, distance between x comma 2. You have to take the minimum, that is pi of x. Okay, now we take a point x here to the left side of 1. Okay, then for this point 1 is the shortest point. Okay, because this distance is clearly less than this distance. Okay, so if you take any point here, the pi of x value will be this distance between x comma 1. Therefore here the function behave like distance between x comma 1. Similarly after 2, the function will behave like distance between x comma 2, because for the points here 2 is the closest point. Therefore this minimum value will be equal to distance between x comma 2. Okay, so also note that if you go to the right side, the distance is increases, therefore it will be an increasing function. Here also if you go to the left of 1, so this point has so this distance between this point and this point, and this point is this point, this distance is larger than this distance. Okay, so here this function is goes like this. So the graph of the function, we know to the left of 1 we know how it looks like, to the right of 2 we know how it looks like. So we have to understand the graph of the function in the interval, open interval 1 comma 2. Okay, so at the point 1 and at the point 2 the function pi of 1 equal to 0, pi of 2 equal to 0, because one of this value will be 0 or this value will be 0, therefore minimum will be 0. Okay, now in the interval open 1 comma 2, suppose if I take a point x here, okay, then for this point 1 is the closest. Okay, so in this region pi of x will be d of x comma 1, I mean in this open interval. Okay, so also if you go to the right side of 1, the distance will be increasing. At the point 3 by 2, the distance will be half. Okay, now if you take a point here, this distance between x to 1 will be larger than distance between x and 2. Therefore here in this open interval the function pi of x will be d of x comma 2, and as you go towards right, go right towards 2, the distance is decreasing, so the function will go like this. Okay, so now this is how the graph of the function looks like, and you can you can visualize that like there is you can clearly see that there are three sharpness for this function. So from that you can immediately conclude that at these 3 points the function is not differentiable, but already you can see that it is clearly a continuous function from the diagram itself you can see. Okay, so here this is one way of seeing this function is this fourth option is the correct option, but maybe you are on, if you're wondering why the function is not differentiable at these points, then we will use the second approach. Okay, so now the function pi of x is equal to minimum of mod x minus 1 mod x minus 2. Okay, so so this is, yes, f of x equal to, if you take f of x equal to mod x minus 1, that itself is a function. Okay, g of x equal to mod x minus 2, if I define, then this f and g are two functions from R to R. Okay, so this here pi of x is defined as minimum of two functions from R to R. Okay, we have a nice formula for maximum of and minimum of two functions. So maximum of f of x and g of x equal to 1 by 2 times f of x plus g of x plus mod f of x minus g of x. Similarly, minimum of f of x comma g of x equal to 1 by 2 f of x plus g of x minus mod f of x minus g of x. Okay, so note that so these functions minimum and maximum, these are all functions from R to R. Okay, so when you substitute an x, the function will check whether which value is lesser, and the lesser value will be assigned to the value of pi of x. That is why it is called minimum function. So for some values this could be minimum, for some value this could be minimum. Okay, so this function like give from two functions f of x and g of x, by using minimum we have constructed a new function. Similarly maximum also. Okay, so now this why minimum of f of x g of x equal to this function. Okay, so if you rewrite this expression, maybe you can write it as 1 by 2 times f of x plus g of x, then again minus mod f of x minus g of x by 2. Okay, you can, I'm just splitting 2 separately. This is separately, and this 1 by 2 is common for this term also, so I have put it separately. So if you look at this quantity, this is average of these two quantity, and this is from this average we are subtracting the distance between f of x and g of x by 2. Okay, so let's see why this equal to minimum. So you take two real numbers a and b in the real line, then their average a plus b by 2 is nothing but the exactly middle point. Okay, so in this line segment you take the middle point, that will be a plus b by 2. Now if you calculate this distance, that will be mod a minus b by 2. Okay, maybe I'll write here, maybe I need to change the color. Yeah, So this distance is mod a minus b by 2, because this full distance is mod a minus b, therefore the half distance is mod a minus b by 2. Full distance, this remaining this half distance is mod a minus b by 2. Okay, now this is a, this is b. Clearly maximum of a and b, it will be b. Okay, how do you get b? With a plus b by 2, if you add mod a minus b by 2, you will get b, correct? Because with this point, if you add this distance, you will get b. Similarly, from a plus b by 2, if you subtract mod a minus b by 2, you will come back to a, which is minimum of a comma b. Okay, so the same idea with the average of two functions. If you add the distance between them, if you add half the distance between them, you will get maximum, and from the average, if you subtract the distance between them, half the distance between them, you will get minimum. Okay, so now we understand why these two formulas valid. So given this, we will so now we can rewrite minimum in terms of this formula. So minimum of mod x minus 1 and mod x minus 2 equal to 1 by 2 f of x, 1 by 2 g of x, that is mod x minus 2, minus modulus of f of x minus g of x. Okay, but f of x itself is, so I have put a, this is modulus of mod x minus. So f of x itself is mod x minus 1, g of x itself is mod x minus 2, and this modulus I am putting here. Okay, so this is my pi of x. Okay, so now if you notice that, so here just one thing we need to remember is the function mod x is not differentiable at 0, and if you look at mod x minus a, that is not differentiable at the point x equal to a. Okay, so even if you take modulus of sine x, okay, then wherever the function sine vanishes, at those points mod sine x won't be differentiable. Okay, that is the idea. So here you have mod x minus 1, therefore this function will not be differentiable at the point 1. Here you have mod x minus 2, therefore this function will not be differentiable at point 2, x equal to 2. Here you have this big modulus. So this because of this modulus, wherever this in the this inner function different, wherever this quantity vanishes, this function won't be differentiable. But when we will get mod x minus 1 minus mod x minus 2 equal to 0, so mod x minus 1 minus mod x minus 2 equal to 0 means that mod x minus 1 equal to mod x minus 2. But for what x, you will get mod x minus 1 equal to mod x minus 2, that is precisely to the point 3 by 2. Okay, 3 by 2 is the point which stays at the equal distance from 1 and 2. Therefore, if you put x equal to 3 by 2, these two values will be equal. So this modulus, inside this modulus you will get 0, therefore at 3 by 2 also this function is not differentiable. Okay, okay guys, so if like you, so now you know the function pi of x, so you can calculate the left derivative and the right derivative at the point. You will see that they are not equal. Similarly, at this point also you can calculate the left derivative and right derivative. So left derivative, right derivative at these 3 points, you can convince yourself that the limit is not the derivatives not exist at these points. So simple argument is like using this mod x argument also, you can see that these functions are not differentiable at these 3 points. Now, in the 2012 June, a similar problem is asked. Instead of the set I equal to, so singleton 1 union singleton 2. This is the set is we saw. But in this problem, they changed the set I to close 0, 1, and the options are pretty much same. Okay. For this set, they have given suitable options. Okay. So, using the same idea, you can do what you do, you draw the graph of this function, graph of pi of x. Okay, using the same idea, then you can clearly see the points at which the function is not differentiable. Okay, so the option is 3, the function is not differentiable at 0 and 1, but that you can check by drawing the diagram. Okay, note that here we take x at various places to draw the diagram. So similarly, you take the you draw the diagram pi of x in a similar way, you will see that option 3 is the right answer. Okay, okay guys, if you learn something new from this video, Please click the like button and share with your friends. Thank you.